In this video, we'll be going over the homework on remainder theorem. So for some of the questions, I did long division, and for some of them, I did synthetic division. So hopefully you've seen my lesson on synthetic division. Otherwise, the notation would look really weird. Okay, so question one, basically perform the division. I could have done synthetic, but I started off by doing long division just in case you didn't watch a video on synthetic division. I did it in quotient form, state the restriction, verify your answer by basically doing the expansion, multiply the dividend with the quotient, and then add the remainder. It's an identity, so left side has to equal right side. If it doesn't, that means you did the division incorrectly. For question two, basically do the division over and over and over again, and state the answer in quotient form. Don't forget your restriction. So for some of them, I didn't do synthetic division because the factor was not in the form of x minus, like this was 2x plus 1, and this was 3x minus 2. I could have used synthetic, but you have to manipulate your quotient, which I don't advise a student to do. But if you really want synthetic, you can, by all means, you can do it. Okay, so for question three, you're basically checking the identity. So you multiply constant terms and add the remainder, and it has to match up to the right side. So you can solve for the remainder that way. For question four, I have a square base prism. There's two ways of doing it. I know that the missing factor must be x minus 4. Okay, I'm going to teach you this method later on, but you know it must be x minus 4 because this is an identity. Okay, so 4x squared, and I know this must be a linear factor because it has to be quadratic times linear to get cubic. So 4x squared times a linear, this quadratic times a linear factor. So if this is 4x squared, this must be x. Well, how do I know? Because I have to multiply to 4x cubed. And this has to be negative 4 because the only way to get negative 36 is if I have 9 times negative 4. And then I factor, and then I know the dimensions of the box. Now, if that was too much for you, then you can just do long division, and you'll be able to get the same thing. You'll get able to get x minus 4. And they said if x equals 5, what are the dimensions? It'll be 7 by 7 by 1 centimeter. And this one you can't do synthetic division because your factor is not x minus k. It's 4x squared minus 12x plus 9. It's a quadratic factor. So there's definitely, there's no way to do synthetic division. Okay, so next question 5. So question 5, they asked me to use remainder theorem and find the remainder. Beautiful. So let f of x equals the dividend, and then f of 4 because divided by x minus 4, and so forth and so on. Number 6, they gave me the remainder when you divide by x minus 2. So p of 2 must be equal to the remainder, which in this case is negative 3. And that allows me to solve for C because I have a linear equation after I make use of remainder theorem. For number 7, I have to use remainder theorem 2 times because they gave me the remainder when x is divided, when the polynomial is divided by x plus 1 and when it's divided by x minus 2. Basically, using remainder theorem 2 times, you can solve for k because you get a linear equation. Nothing fancy. Okay, so for number 8, let's see. Use remainder theorem to determine remainder. Beautiful. So you're dividing by the factor 3x minus 2, so find f of 2/3. 9a, find the remainder using 2 ways, using remainder theorem and using long division. And in both cases, you'll get negative 1. But this question is basically highlighting how beautiful remainder theorem is. You don't have to use long division to find remainder. Okay, just use the remainder theorem. Okay, question 10. Determine the remainder when it's divided by 2x plus 1 and you get 0. That's actually very special, but we'll talk about it in the next lesson. 10b, they ask us to factor. You can common factor the x and then use your grade 10 factoring techniques to factor this complex trinomial. Question 11, very common test question. Basically, you have two variables, m and n, and you use the remainder theorem 2 times to build a linear system, which will enable you to solve for m and n. I chose to solve it using elimination, but you can use it. You can solve it using substitution.